Hello everyone, welcome to yet another session of Lockdown Technical Webinars. This webinar is part of a weekly webinar series for IT undergraduates to enable you learn new stuff while staying at the home. The webinar is organized by the Regional Development Forum of SLASSCOM. If you miss this webinar through Zoom meeting, you can even log into Facebook. The same webinar is um, can be seen on Facebook through the SLASSCOM Facebook page, facebook.com/SLASSCOMLK. After the webinar, the same video will be made available through the official SLASSCOM YouTube channel. So please search SLASSCOM Sri Lanka in the YouTube and subscribe to our official Facebook YouTube channel and to watch these recorded sessions of technical webinars. So we have arranged another technical webinar series for coming weeks as well. So you will be able to see the flyers and the notifications every Monday through our SLASSCOM official social media channels. Today, we will be covering a very important topic for your software developer careers. So we have um, Rajika Imal, who is a senior software engineer at 99X, to talk about clean coding practices, which will be very important topic for every developer. Over to you, Rajika.
Yeah, hi guys. So hope you all can hear me properly. Yeah, so as Isuru mentioned, we are going to discuss or we'll take a look at clean coding principles, and we are going to take a look at the examples in C#. And a bit about myself, I'm working as a senior software engineer at 99X, and if you have any questions, you can find me in any of the platforms with this handle, Rajika Imal. And yeah, so let's get started. So I hope most of you are undergraduates. Most of you who have joined this webinar are undergraduates, and so as undergraduates, we are looking to become a software engineer. So you are all aspiring to become a great software engineers. So you need to have a certain set of skills to develop enterprise software. All right, so let's take a moment to forget about software industry, and let's take a look at the construction industry and what they're doing. So for an example, let's say the engineers who are involved in the construction side of things, and the people who are really implementing the things, they are working according to a plan, right? And they are implementing certain fundamentals and concepts and theories, and they are building their things on top of those fundamental concepts and theories. But even if you use those fundamentals and the theories that you learn, there can be places, even if you are applying those things, there can be issues and problems that arise when you create certain structures. So for an example, even if you follow certain fundamentals, you can create brittle structures if you think about constructions, and these can lead to unstable and unusable structures. So in a similar manner, if you think about software engineering, you need to learn about fundamentals. That's 100% true. You need to learn about the computer science theories and proper software engineering theories. that you are going to use when you are implementing an enterprise software. But if you do not properly apply these concepts and in a manner that you can create a proper solid enterprise software, it wouldn't matter, because when you are in your undergraduate period, you are thinking about creating a software that just works. But in the case of the industry, when you move into the industry, that's not the case anymore. Yeah, so let's take an example. So let's assume that most of you are in third year or fourth year, and you are creating your projects. And one of the key things that you are focusing is that you are focusing on the deadline. Let's say you have 4 weeks from now to implement your project, and you are just focusing on that, and somehow you are trying to come up with a software which works and that you can present. So we are all doing this. So even as undergraduate, I even did this. And uh, uh, so if you think about the deadlines only, and think about a software which just works, that's going to be a problem when you come to the industry. So the focus of this session, the major focus in our session is to give you guys a proper idea about how to apply these proper concepts and fundamentals related to clean coding concepts, and create some good last long software, so that the cost would be much lower when you compare to software that are being created without implementing these proper clean coding concepts. So I hope that you all have a proper idea of what we are going to look at today, and the reason why we are looking at the clean coding concepts. And yeah, so another thing about the industry, so when you work in a company, it's so when you create something, it's your own thing. So if you write a particular set of code snippets, it's your thing. So you have to be extremely careful of what you do. So that's what we call as extreme ownership. So you have to own what you do when you are in the industry. So you are responsible for what you write, and we can track what each of the persons are doing in the project. And if something goes really wrong, so we can track who did that and what went wrong. So you have to be responsible for what you do. So it's not, so compared to what you do at the university and compared to what you do at the industry, there's a little bit of a gap, and that's where we want to fill in with this clean coding concepts. And hopefully we will be able to do that. We will be able to get a head start for you guys with this session. Yeah, so these are the concepts that we are going to take a look at today, and there are 4 concepts. And before going into these concepts, let me tell something about the examples that we are going to look at. So these examples will be extremely simple, but after you finish this session, if you take a look at your university projects, so if you are in a third year or fourth year, or maybe any level, you can take a look at your projects and see whether you have applied these extremely simple scenarios. So I'm pretty much sure that most of us are not applying these very simple concepts at the university level. But even if you take a look at the very simple examples that I'm going to present, there can be many things that you can learn, and the cost would be much lower when it comes to the enterprise grade software. All right, so let's take a look at this clean coding concept, and so we are going to look at 4 examples. Yeah, so the first one is dry, don't repeat yourself. So when it comes to dry, it simply means that we do not need to have repetition in our software. So as software engineers, or as engineers, we are mainly focusing on reducing the repetition. So even if we forget about coding, if we think about something related to infrastructure, we are trying to create scripts. For an example, we are creating shell scripts to do certain things so that we do not do them repeatedly manually. So that's one of the examples that where we apply our tools and skills to mitigate repeating. So similarly, in your coding, you have to apply those concepts. The don't repeat yourself. So in short, you don't a piece of logic should not be there in many parts of an application. So it should be at a single part of the application. So that's what we call as don't repeat yourself. So we will take a look at around the 3 examples. So the first one is magic strings. So magic strings can come in certain forms. So these are hard-coded values that shows up at random different places. So if you think about your undergraduate projects, they can, for an example, it can maybe 100 lines of code per class or something like that. But when it comes to enterprise level software, it's very
Hi everyone. Can you all hear me?
Yes.
Just bear with us. I think the speakers, there's some technical issue. Just bear with us for 1 minute. We will be able to start it again soon.
Hi guys, hope I'm back online. So can I get some kind of message from any of you guys to confirm I'm back
Yes.
online? Okay, great.
Sorry for the inconvenience, guys.
Yeah, sorry about that.
Rajita just experienced some connectivity issues. Rajika, you can start from the magic strings. So I think entire slide
Okay,
has to be
yeah, all
explained
right.
yet.
Okay, so so now we are still we are at dry. Don't repeat yourself, and we are looking at the first example, the magic strings. Magic strings. So these are hard-coded values that shows up randomly at different places. So when you compare it to your projects and the projects that we are building at the enterprise level in the industry, it can be really hard if you do these hard-coded values at different places of your source code. So for an example, in your project, you might have only 2 or 3 modules, but in an enterprise project, there can be thousands of modules with different interactions and dependencies. So if you have different constants and connection strings at different places which pop up randomly, and if you try to change one of these values, and you might not know what would be the side effect of changing such a value. So there can be a chain of reactions that might occur when you do these changes if you have values which are there randomly at different places of your source code. So it's not a good practice to do that. So it can be a constants or connection strings, and there can be many other examples as well. So this is a C# example of how you can have this is a bad example of how there can be magic strings which pop up randomly at different places. So this is a console application, and we have the main method here, and there are 4 methods, and within these each method we are trying to print out a simple value with a certain formatting. And as you can see, there are 2 variables, address and format, which are repeating. And so obviously you can replace these values with the constant. So as a solution for this, you can create a different class with constant, and you can create a static variable. So previously we had address and format. So we can move them to this class constants, and they will be static, and we can use them easily without repeating ourselves in the code. So in this particular case, we are using the constants class with these static variables. So and one thing to note here is that these concepts, these can be applied to different languages. So these are not particularly restricted to C# only. So you can do these things in most of the other languages. And another quick note is that you can have different languages which implement different paradigms. So for an example, we have object-oriented paradigms, and we have functional programming paradigms. So likewise, we can have a different paradigm. So in our case, we are looking at the object-oriented paradigm, and most of the examples will be based on the OOP concepts here. Yeah. So next, we will have a look at magic numbers, pretty similar to magic strings. So in this case, we have a static method which tries to get a list of employees. So we have a list, and now I want to get my first employee. So for any reason, there might be a certain logic which states that you have list and you need to get the first employee for, and there can be many reasons for this, and it depends on your application and depends on your logic that you're going to implement. So this is one such example of getting the first value of a list. And here we are trying to access our employee. So this is actually the second value. And so you can see that we have used these hard-coded values. And so rather than hard coding it, so we have many places here. So 1, 2, 3 places. And rather than doing that, we can again create a constant index of my favorite employee. So in this case, I'm trying to get my favorite employee, where we assume that the favorite employee will be at the first place of the second place of our list. And so after implementing that, what we can do is we can replace our index with this constant that we created earlier. So here we are using our constant, so that if you need to make a change in the future, you do not need to go to the source code and change 3 different places. It's just one place that you need to change. So that's a very simple example. So I'm pretty sure that you are doing this in your undergraduate level projects. So these are very simple, but when you are implementing these things, thinking about the deadlines and thinking about what we need to implement and the features that we need to implement, we do not think about these best practices. But if you get a habit of implementing these best practices, it will come to you naturally when you are joining the industry. Next, we will take a look at some of the repeated logic. So we have a class called consigner. So consigner is actually a shipping provider in Norway. All right. So within this class, we have ID, address, and a value that we can identify whether this can be a consigner or not. So the idea is to calculate our ID for this particular class. So we are using this string. So here the naming can be improved. So we can just make these values a simple case. So that's an improvement that we can do here. And if you take a look at this constructor, we are using this string, and then we are trying to calculate this the ID. So we have this private method which calculates the ID based on the time. So it's a pretty simple method. If we move forward, we have another class which is pretty similar, and it has some extra details. So nothing fancy, but some extra properties there. And so you saw that we have 2 providers, consigner and uniform TMS. So what we can do is we can take those common common properties and the common behaviors. So so you need to think about the object-oriented principles that you have learned earlier, and you need to think about those properties. So inheritance, encapsulation, abstraction, and the other things that you are learning, composition, and yeah. So yeah, so what we are trying to do is we are trying to create a parent class. So I have named that as a shipment base here, and I have moved all the common stuff, the common properties, ID and the address, and we have a constructor, which is if you take a look at these previous classes, they are doing the same thing except for the type of the carrier that we are going to apply. So that's this one. So we take it as an argument, and we have the same calculate ID method, the private method that we had earlier in the previous classes, and we take it up to our parent class. So how do we implement it? We can use our parent class when you're implementing our provider. So in this case, it's a consigner. And yeah, so if you want to override certain things, you can do those things here. And so basically what we are trying to do here is that we are providing our a value so that it will be used here when we are calling the constructor. Yeah, so that's one of the examples that we can implement to reduce the repeated logic. All right, so we talked about a few things here, and so we talked about a dry, and next we are going to take a look at YAGNI. You ain't gonna need it. So so when you are in the industry, you might meet some people who says that you need to implement these certain particular features thinking about the future, but nobody can say about the future, and nobody can't predict about what kind of requirements that you might get in the future. So that's not actually a good idea if you're implementing an enterprise grade software. So YAGNI, you ain't gonna need it. So you are implementing each and every feature thinking that thinking only about the current requirements, current state of the software, and you do not do any assumptions based on your thoughts or based on your own requirements, such things. You only try to implement your software based on the current requirements that you have. So always implement features only when you need it, and don't foresee them and build out assumptions. So like I said, do not make assumptions and build certain features upon those assumptions. And you should be used with other practices such as continuous refactoring and unit testing, and also CI, continuous integration. So continuous integration is kind of a topic which goes along with DevOps, but we do not need to consider those aspects since we are in here. So moving forward, this is a very familiar image. So if you know about Martin Fowler, you must have seen this if you have searched about YAGNI. And Martin Fowler, he states these 4 types of costs that we will get if you do not follow YAGNI. And for an example, if you take the wrong features that you're going to implement, so it will introduce the cost of building and also the cost of carrying and the delay. So if you implement a wrong feature based on your own assumptions, it will introduce these 2 costs. And next we have the right feature built wrong and also the right feature built right. With right feature built wrong, we might introduce the cost of repair. So if you build a right feature, but still it's built in the wrong way based on certain assumptions that you make at the earlier design stage or maybe in the implementation stage, you might introduce the cost of repairing those mistakes that you did. So it can be a certain cost. and also the cost of carry and the cost of delay. So similarly, you have the cost of carry and the cost of relay for right features. And even if they are built right, certain refactoring might come up in the future. So yeah. So this is a very simple example of YAGNI. So we can think about the HTTP clients that we are using when we are building, let's say, an integration platform. So if we have a certain platform and we want to do HTTP request to an external source like a REST API or source API, SOAP API, or anything like external source which gives us information. So there are two options. And before going to that, let's make an assumption like we need to pass the response in a certain manner, that we might need to implement these things in different places. So there can be a few things that we need to think about when we are doing such an implementation. So do we need to implement this passing logic within the same method, or can we split this passing logic to a different helper class, or can we wrap this class within another class? So those are the kinds of options that we have, and we need to explore such options before going ahead. So if it's very simple application and you are very sure that there won't be any changes for this feature, and it won't be touched in the future. So you don't implement passing in a different class or a wrapper class or a helper class. You can do that in the same place. But if you are very sure that you will use this certain passing logic at different places of your logic, or the different places of your code, you need to consider about implementing these helper classes. So one such example is the file helper. So let's say you need to implement a file reading mechanism, and there would be a passing scenario. So you can create these classes, helper classes, and there can be interfaces if that's necessary. And this is an example of a reading file, reading a text out of a file, a very simple example. So you can use helper classes if you want to decouple your logic. And before doing this, you have to think very thoroughly whether you are going to use this helper class in any other places, or is this something extra that you're going to do. So that's YAGNI is all about. Next, we are moving to KISS, keep it simple and stupid. So some people, some engineers might be looking at your code, and they might tell you that this is very simple, and you need to implement these kind of extra layers, these kind of extra design patterns to implement this certain piece of logic. But it's always good to start very simple and build upon that. And I think with experience, you might get the differentiation of the simplicity and the over engineering part. So that might come up with your experience. So you need to actually do these things. You need to implement an enterprise grade software, and you need to interact with your teammates, your technical leads, your technical architects, and get their own opinion about how it's going to be a simple implementation, or is it are we going for an over engineering part here. So that might come up with your experience of interacting with each other when you're working in an environment of creating enterprise grade software. But it's always good to start with the simplest design and implementation, and you need to consider complexity at every stage of your software development life cycle. So you can start from design stage up to the implementation and shipping your code to your end customer. You can think about the complexity when you are doing that. So even from the very first step, you have to think about the complexity. And it's always good to have a simple solution and better than a complex one, even if it looks stupid. It might look stupid, but if you think about the costs related to software development, it might be a good idea to keep it very simple and stupid at the start. And you need to have a certain idea about where you are going for the over engineering part. And you need to think about that aspect as well. Yeah, so best code is deleted code. If you can remove the number of if you can remove a chunk of logic and implement it in a certain manner that it requires a less number of code, it might be better, but it's not the same case for every implementation. There can be some exceptions. Yeah. So with keep it simple and stupid, we will take a look at refactoring, dead code, global state, lasagna architecture, abstraction and dependencies. Yeah, first let's take a look at lasagna architecture. So most of you might not have heard about this term lasagna architecture. So what this means is that we are trying to introduce many layers to our software, and these layers might complicate what we do. And if we need to do a refactoring or a simple change to our software, we might have to change many layers in this lasagna architecture. So examples, so this is an example of lasagna architecture, but it again depends on what you're doing. And if this if it's very necessary to have all these layers, then we can't do anything about that. But it's always good to have good to start with a less number of layers and build on top of that, and keep an idea about whether we are going for a lasagna architecture and spaghetti code. So I will go into this spaghetti code in the later slides. So these are few examples, example layers. So API layer, which receives the requests, and the API wrapper layer. And then we might have a validation layer, which we validate our inputs. So for an example, if a user is logging into our system, we might get username and password from our API, and there might be a validation layer which validates this information. And then if you think about the ASP.NET or ASP.NET Core, we have controllers, and there we have dependency injection. So don't think about those things very deeply, just think about them at a high level. And again, within the controllers, we might have factory implementations and different design patterns. So this is an example of a design pattern. And next, we might call the model layer and the CRUD implementations: create, read, update, and delete. And if it's an integration kind of scenario, we might need to talk with an external server, external service, which can be a REST, SOAP, or maybe even GraphQL. So that depends on the thing that you're going to do. That depends on the scenario and use case that you're going to do. And based on that, there can be many layers that you're going to introduce in order to divide and use different logics in the certain layers of your application. But you have to keep in mind that you need to have a good idea about whether that you are going to over engineer things, and you have to keep it very simple. So abstraction, a very simple example that I can show in C# is that assume that we have a shipment handler. So we are going to ship a certain thing, and we need to ship it and update stocks. So a person might implement this ship shipping and updating logic in the same method, but that's not the ideal case. We can divide this logic into two different methods. It can be a ship and then update stocks. So in the future, if you need to change anything in the update stocks, you can just change it only within that method. So that's going to be helpful when you are doing refactoring in the future. So that's a very simple example of refactoring and refactoring with the abstraction. Dependencies. So dependencies, if you haven't heard about the term, I'm pretty sure most of you have heard about dependencies, but just to be 100% sure that we are on the same page, let's take a look at a few of the modules, module A, B, and C. And we have module A, which is dependent on module B and C, which means that module A cannot function without module B and C. Yeah, so this is a very simple example of dependencies. And I have included an example with ASP.NET Core on how you can implement a dependency injection. So dependency injection is pretty much the dependencies that we need to include for our application or the different modules to function properly. So that we can do things like unit testing and integration testing properly. Yeah. So this is an example of adding adding a dependency with a singleton. So there are three ways to add dependencies, dependency injection in ASP.NET Core. You can just go to the documentation and take a look at those three different ways. So this is one such way to add a singleton. So this is using a design pattern. I'm 100% sure that you have heard about singleton if you are second year or third year or fourth year student. Yeah. All right. So next we are moving into a separation of concerns. Yeah. So the different types of concerns that we have, they can be user interface and the presentation logic, the business logic, and the database logic that you are going to implement. So these can be different concerns in our application. So most probably in web applications and desktop applications even, these can be the major concerns. And when we are separating different logic, we can think about the separation at the function level and also at the classes or object level. And if you take separate modules which have certain logic in a certain modular fashion, or which contain certain logic in like if they have a certain logic which are related to each other, we create modules and we can do modular implementation. For an example, in C#, we might create different projects to implement different modules. And in a language like Go, we might implement different packages or modules. So they have the idea of packages and modules within the language itself. So for each language, there can be different concepts on how you implement these things. But if you think about the paradigm, if it's an OOP language, then most of these concepts you can apply to your implementation. Yeah. So moving forward, we can even take a look at a high-level architecture like MVC. Hopefully you have heard about MVC, the model view controller architecture. So that might come in handy when you are creating. So nowadays, most of these frameworks like ASP.NET and .NET Core and things like web frameworks implemented in most of the languages, they have baked in these architectures like MVC. So you don't have to implement these things from ground up. You just need to learn the concepts and try to apply it properly with these architectures. So coming back to what we discussed in the earlier slide, the separation of functions, we can think about our algorithms that we implement in the function level and this spaghetti code. So in this case, we can decide whether to on how to abstract certain things properly. So we discussed about abstracting earlier with a simple example, but here also we can here also we can think about proper abstraction with the separation of functions. So an example can be algorithm implementation or a certain piece of logic which does a certain thing, and we can avoid this spaghetti code scenario. Next, we have the separation of things, or separating things with classes and objects. So here you need to be careful about creating God classes. So an example would be a class which does many things. So that's not the idea of object-oriented design. You need to have different entities which have proper states and the proper properties and the behaviors which encapsulate in a certain class. So this is a very good place where you can think about your object-oriented designing skills and also the object-oriented programming skills. And if you have done it correctly, most of the time you might avoid these God classes and this spaghetti code that you might implement. So this is where you can correlate your object-oriented designing and implementation skills to this clean coding concepts. And next we have separation of modules. So module implementation can be different in different languages, and according to your team as well, there can be different terminologies that you might use. But if you modularize your code properly, you can avoid monolithic applications which might be a bad scenario if you are moving to different architectures in the future. So if your code itself is a very big, very huge monolith, it can be a huge disaster. But if you have separate modules implemented within your monolithic application, you can break them easily apart, and your dependencies can be identified very easily. So one example, one scenario can be where if you are moving your monolithic application to, for an example, let's say microservices, you can easily create different microservices based on your modular implementation. So that can be based on your domain. So one thing is we can use domain-driven design to divide different modules within your monolithic application. So that's one of the examples that we can think of, and one of the advantages that we might get avoiding these monolithic applications and building proper applications with a modular implementation. And this is just a very simple example. I'm 100% sure that you might have used Visual Studio and IntelliSense. In most of the IDEs and text editors nowadays, we are having IntelliSense. So when you are developing enterprise grade applications, there can be a huge number of modules and different classes, and we need to make use of these different tools and technologies to be productive. So one thing is that we can use IntelliSense. So 100% sure that you might have used IntelliSense, and so the idea is here to properly give you an idea about the usage of tools and technologies that you might come up with when implementing your software, and also in the industry. You need to properly use these tools in order to have a proper productivity and implement these good concepts in your source code. Okay, so we discussed about a few things. So as I mentioned, when I was starting, I mentioned that you might have not applied these concepts. For like 80% of you might have not applied these concepts to your undergraduate project. So I'm pretty sure, because I have even done, I haven't even applied when I was an undergraduate, so I wasn't 100% applying these concepts when I was an undergraduate. So this is where you guys can get a head start, and you can be thorough about what you are going to implement in your software. So these are very simple things. So as you saw, you need to create just simple constants and use them in different parts of your applications. And when you're doing this, you might feel that you are productive. And even if you are thinking about certain things for a particular time, when you're implementing certain things and when you're doing refactoring, that might come, those ideas and concepts that you implemented earlier might come in handy, and it might save you a lot of time. So even though you are working for a deadline, think about how you can apply these object-oriented concepts and the clean coding concepts properly, so that you might actually end up saving time rather than just blindly going through the source code and changing certain things. And in the future, you might have to refactor certain areas of your source code, and there can be a chain of reactions, and you might not know what's happening as a result of these reactions. So so one thing I can note is that
Excuse me, Rajika, I think we can't see your screen. Did you lost screen sharing? Yeah, now we can see. I'm sorry. Yeah. Rajika, we can't hear you now.
hello.
Yeah,
I guess
now,
I'm back.
yeah. Okay.
Yeah. All right. So like I mentioned, you need to correlate these object-oriented programming skills, object-oriented designing skills with the plain coding concepts, and you need to compare it with the implementations that you have done now with your undergraduate projects, and see whether you can do a certain refactoring, and you might save a lot of time with these simple things. So these are very simple things, but you will be surprised with the time that you might save with these simple refactorings and the simple changes and the concepts that you apply to this source code. So as the last part of our presentation, we have ASP core clean architecture. So this is like an extra thing that we decided to present. Yeah, I think we have a few people who raised their hands. Are we taking questions at this stage, or is there a separate Q&A?
You're free to take questions.
Okay, yeah, great. So if they can somehow yeah, few people raised hands. So if you still have a question, I think
maybe
yeah,
just
you
paste
can
on the chat.
Yeah, I can give you answers. Yeah. All right. So we are looking at the ASP core clean architecture. So ASP Core is like the next generation of ASP applications with the Microsoft ASP framework. So with the clean architecture, we have this onion model. So with design patterns and the basic concepts of programming, you might be learning about these different models and the design patterns. So this is one such pattern we have used. So even in the operating systems, they have some operating systems are implementing this onion model. So similarly, we have this clean architecture template. So this is basically a template provided by Microsoft to start a project with this clean architecture model. So at the so if I can point it to you, we have these entities, use cases, controllers, gateways, presenters, and at the outer layer we have the web UI, and we have few different things. So basically, what they are trying to do is they are trying to create different layers based on the onion model. So for an example, entities can be plain old C# implementations, and there might not be any extra things here in this layer. So likewise, when you are going towards each layer, we can consume the layer below and build functionalities around that. So that's the basic architecture or the basic idea about this onion model. And next we have the layers, different layers that come up with the clean architecture template. We have the user interfaces and the infrastructure and the application core, and we can have unit tests as well, and also integration tests. Yeah. All right. So if you need to create a project starting with this clean architecture template, so if you have used Microsoft ASP.NET or ASP.NET Core, you might have used different templates like MVC and Web APIs or REST. And so similarly, this is a template that is given by Microsoft to implement the clean architecture. So this is how you can start a project. Go to this GitHub repository, and they have these commands to create this project based on the clean architecture. So this will give you a head start of how you can start using these clean coding concepts along with this design pattern, like with this onion model or the architecture. So this is like an extra part that we thought about presenting to you, so that you might have some sort of an idea about how to separate different modules. So when you're creating this project with this clean architecture, you will get 3 projects, as I can remember, if I'm not wrong. So take a look at these templates, and these are kind of the best practices that you can use with ASP.NET Core. So this is one such example, and there can be many examples when it comes to different languages and different frameworks. They might have their own best practices and templates based on the best practices. Yeah, so that's what we needed to give you guys today. And like I mentioned many times, these are very simple concepts that we presented today, but go back and see whether you can implement these very simple things. And I'm pretty much sure that you might do refactorings to your source code. So yeah, so I guess we can take questions now. Okay, we have a few questions.
Guys, if you have any questions, you can type it in the chat.
Yeah, you can unmute yourself and ask question, or else you can chat.
So one question is that are there any issues when you are using these concepts with like a different framework or a different language, I guess. Like here in this case, Menak has asked about Spring Boot maybe in Java. So like I mentioned, so this is not particularly limited to one of the languages or these frameworks. So here today we showed you C# and along with ASP.NET Core and ASP.NET Core examples. But you do not have to be restricted to a certain language or a certain framework to implement these best practices or clean coding concepts. So the only thing is that these align well with object-oriented designs and object-oriented programming implementation. So if your language is based on object-oriented paradigm, then you can 100% you can apply these clean coding concepts, the concept that we discussed today. There is no issue with that. Okay, we have another question. The question is that I'm in second year of my degree and I know basics in program, but how can I learn most advanced in program, advanced concepts in program, and I mean to make myself align with the job market? Yeah. All right. So when you are in the undergraduate level, you are first learning about the basic fundamentals of programming, like the procedural programming with C maybe, and then you move into another level like C++, and you move to another language with object-oriented capabilities like Java or C#. And so I think that you are currently in that level. So most probably if you're in the second year of your degree, then you are mostly familiar with object-oriented programming concepts and the object-oriented designs. That's from my point of view, that's what you need to implement these best practices, and what you need to build upon that. And if you have a good fundamentals in object-oriented programming and other concepts like data structures and algorithms, that's what matters, because all the other things that revolve around us, they are built on top of these fundamental things. So for an example, if you do not know how to manipulate your data structures, and you do not know how to properly code algorithms, then it doesn't matter if you know the MVC architecture. So you need to be thorough with your fundamentals, and even so if you are thorough with your fundamentals, you can go ahead and learn the advanced stuff like applying the clean coding concepts and applying design patterns. So if you're in your second year, you might be learning about design patterns. So that might be the next level for you, trying to apply the design patterns, and try to see where you can apply this. So before coding everything, you have to think about what you're going to do. And so when applying design patterns, one thing I can comment is that you might do some over engineering when it comes to design pattern, because you might think that you need to apply these certain things in certain areas. But as I mentioned in the earlier in the presentation, you need to keep it simple and very stupid. So you need to keep your level between your simple implementation and your over engineering implementation. You need to think about that, and that might come with your experience by interacting with your leads when you are in the industry. But what we expect is that you need to know about your fundamentals and your design patterns, what you learn in your degree period. So if you can do that, you can learn about applying these things properly when it comes to enterprise software when you come to the industry. And so what you need to do is you need to learn how to apply the design patterns and the clean coding concepts and architectures. And the over engineering part, it comes with the experience. So in my point of view, yeah. So I hope that explains an answer to your question. All right. The next question, what are the similarities in these concepts when applying to single-paged applications such as React? Okay, so we can take a lot of things. So for an example, if you can remember, we used constants without repeating ourselves. So that's a very simple scenario of where you can use these things. So JavaScript, it can be an object-oriented programming language, and also if you're using a library like React, then mostly you are using functional programming concepts. So it doesn't matter. So every of these concepts that we discussed today, they do not just need to be aligned with object-oriented programming concepts. They can align with other concepts as well, but the examples that we looked are based on the object-oriented concepts. But so as you have mentioned, the React, it's based on functional programming concepts. But think about these very simple things like repetition and yeah. So we use constants, and so if you are using something like Redux, you might have used constants in your Redux flow. So that's where you can apply these things where you do not need to repeat certain things. So that's an example of how you can use constants and mitigate repetitions. And with components in React, so that's an example of how you mitigate repetitions again. You can use the same component in different part of the applications if it's reusable. So they have also thought about these concepts when they're building these languages and frameworks. So fundamentally, if you think these concepts are baked into these languages, libraries, and even languages itself, the primitives, they might have baked in these examples, or not the examples, the concepts of clean coding. Then you can easily use these clean coding examples when you are using these libraries or frameworks like Angular or React. Okay, the next question is, could you please suggest how to write clean coding resources like GitHub repo? I did not get the question 100%, Kapilan Shrikaran. Like a GitHub repo means, is there a particular example that you can share with us? Or hopefully you can clarify on that. So I will move into the next question. How to select technology, language, and design patterns for a project. All right, so the first one, the technologies and the languages. So this depends on your use case, your customers, and what you need to build for your customers. So for an example, let's say we are building an application which has some quite complex algorithms, and you need to be very thorough about your compute capacity and these resources that we're using. Then you might need to think about a language and a framework or a technology that might be very well, very good with these CPU cycles and utilizing the RAM very well. So for an example, for the algorithm example, I can say you can use C++ or Rust, even if you are going for a newer language like that. And if you think about JavaScript, it's not a very good thing to use JavaScript for your algorithm heavy or CPU heavy applications. So that's an example of how you can select technologies and languages based on your use case. And again, I can take an example of implementing an integration API. So let's say we have an API which calls to multiple different servers or API endpoints such as REST or SOAP. So in this case, we do not need to go ahead with low-level languages such as C++ or even Rust. We can take something simple like JavaScript, Node.js, and implement these IO-heavy features with JavaScript or Node.js. So one of the reasons that I might use this, I might use a Node.js for implementing IO heavy integration API would be that it has this non-blocking mechanism of interacting with the requests. And it would be a good idea to use such a platform which can utilize your CPU and RAM level in a manner that that can be very useful for you as a programmer. And these abstractions that they provide, so if you compare to C++ or Rust to JavaScript, it's a very high level language, and C++ and Rust, they are in a very low level. So if you are going to be productive and if you need to ship certain features very fast, you need to select a language which is at the higher level of the hierarchy. Yeah, and the other thing is he has asked about design patterns and also how to find clean code resources examples. So about the design patterns, yeah, so that's yeah. All right. So about the design patterns from the previous question from Menaka. So again, that depends on your use case. So there can be many different design patterns you need to use. It depends on what you are implementing. So for an example, where you can implement a singleton or a factory, it might not be a very good idea to introduce a singleton pattern when you can introduce factories. So that 100% depends on what you are doing, and I might say that it might come with your experience to a certain level. But at the start, you can just try applying certain design patterns. Then you will get an idea, because design patterns uh, are solutions for certain things that people have experienced in the past. So if you think in that point of view, those problems and the issues that they have experienced in the past, the programmers. So if you think from that point of view, you might actually get an idea about how to properly apply a certain design pattern. Because if you think about the problem, and if you have the same problem, which means that you can apply that certain design pattern. So that's one way of thinking about applying a design pattern. And all right, we have the corrective question. Could you please suggest how to write clean coding resources like GitHub repo? How to find the clean coding resources? Yeah, so from my experience, I would say if you are looking at GitHub repositories, of course, they should be public. And so most of the open source projects, if you take a look at good organizations, for an example, we can take a few of the most obvious ones: Facebook, Google, Microsoft, and Netflix. If you go to this GitHub organizations, you might see these repositories, and one of the things that you can do is you can just go through repositories where you know the language and the technologies, and you can compare it what you have done with their implementation. So you can get an idea about how they have implemented certain things like classes, and how they have separated certain logic to certain methods, and how they used different concepts in object-oriented programming, and try to map that to what you have done. So that's one of the things that I can mention. So from my personal experience, so what I do is I just go to their repositories and just go through what they have done, and get an idea about how they have implemented these simple examples. So that's really important to keep in mind. Just do not think about the complex things, but try to spot these simple things that we discussed. For example, how they have mitigated repetition, so how they have used constants to mitigate repetitions. And yeah, so likewise, you can go through the repositories and get a good example. So when you're even reading code, so it's a good habit to read good code. So I'm pretty much sure that I can recommend these big 4 companies and their code, and they have really good engineers who are implementing a production grade enterprise software. So it's quite okay to read those source codes and get an idea about how to properly implement these concepts. Do you have any other questions? Okay, one question. I'm a computer science student. I can make small programs once DB codes and all combines together. I make mess of those. Any ideas, please? Some motivation would appreciate. Okay. So we all have been there. So the question is that this person, so he or she has created the simple programs connecting to the DB, and once we do that, we create a mess. So the next level for you might be to look at the separation. I mentioned about the separations and how you can do separation at different levels. So you can start from the simpler level. Think about functions and certain logic that you can abstract to certain functions. And if you're using a language like C# or Java with object-oriented capabilities, how you can how you can implement interfaces, abstract classes. Think about in that level. So currently, if you have certain logic, think about how you can refactor that logic to certain functions or abstract classes and interface, how you can implement interfaces. So if you haven't done that, that would be the next level for you. And after that kind of a separation, you can try to apply design patterns. So like I mentioned earlier, you can think about the problems now you have and try to correlate with the design patterns that you learn in your degree program, and try to correlate with the issues and try to apply what you have, what you in your source code. Yeah, so after that, so most probably you might get an idea about what you can do with the separation of concerns and applying design patterns. And the next level would be to apply so applying different architectures like MVC. So if you're using a framework, that can be really helpful, because most of the frameworks nowadays, they come up with baked architectures within them. Yeah, for an example, ASP.NET Core, they might have MVC, and different front-end frameworks, they might apply certain architectures like Flux or Redux. So based on that, you can choose it. So yeah, so I hope I answered your question. So one thing I can suggest you that, as earlier, try to read code from other people. When I say other people, try to go to some quality organizations like Google or Facebook and things like Netflix repositories. You can find many things that they have implemented and how they think about different aspects of coding. I know it can be really tough to read big code, but if you start from simple repositories, you might get an idea about how they have applied these clean coding concepts simply to their projects to simplify their workflow and the productivity. Yeah, so if you take a look at open source projects that looking and reading your code and reading others' code continuously, that can be a very good habit. And try to follow some people on GitHub so that you might get some updates on what they are doing. And yeah, so you have certain role models to follow and what they are doing, and try to try to replicate what they're doing. So one thing I can personally suggest is that try to find good role models and try to replicate things. So that's one thing that has worked for me. Yeah. Okay, I think we are done for today, and I hope I answered all your questions. And if you have any other questions, you can find me in any platform with this handle, Rajika Imal. Yeah, so thank you very much for your time, guys. I guess we are wrapping up.
Thank you. Thank you, Rajika. Thank you, everyone, for joining this particular session. And stay tuned on our social media pages for our upcoming weekly webinars. And let's say if you happen to miss out any of our webinars, the webinars will be recorded and uploaded onto our official YouTube pages and Facebook pages. Thank you. Thank you so much, Rajika.